السلام عليكم ورحمة الله وبركاته. يسعد صباحكم. اليوم راح نكمل section 17.2 and point 3 and we'll start with this example 17.1.3.1. So here in this example we have a uniform 50 kilogram crate. So here we have this crate or box, okay, and its weight or its mass is 50 kilogram. Rests on a horizontal surface for which the coefficient of kinetic friction, so this is the friction with the ground, kinetic friction. Determine the acceleration. We need to find out the crate acceleration, okay, so it is unknown. If the force, this force applied 600 Newton to the crate as shown in this figure. And here is the dimension 1 meter by 1 meter for this crate, and the point of application of this force is 0.8 meter from the ground. Okay, so we need to find out the acceleration of the crate. Now let's move to the solving board. Okay, we have a crate. This crate is 1 meter by 1 meter, okay, and we have here force equal to 600 Newton. Now first thing that we have to do is to determine the positive direction for our coordinate system. So I will choose XY coordinate system, okay, and here is the positive rotation. Okay, now the second thing is to draw the free body diagram. We already start with drawing the given information, which is the force. Now we have here at the middle the centroid, so we have weight downward, okay, we have mass, then we can calculate the weight from multiplication of mass with the acceleration. What else? What do we have? We have the friction, okay, so here is the friction force, F friction, okay. What else? We have normal force. Here is the normal force, okay. Now do we have any other force? No, we don't have any other force. So this is the free body diagram. Now the kinetic diagram, what do we have? We have this crate, and this crate, here is the centroid, and this centroid must translate, so it will have force in this direction, so MAG, translation only. Okay, but here we have a question. First question, how do you make sure that this crate or this box only translates? Let me go back to the slide. So here is the centroid, okay, and once we apply force here, it should do, or it should either translate, so either this box or this crate translate in this direction, only sliding on the ground, or imagine if we have here resistance at this tip, at this edge, okay, what will happen? If we have a step, for example, what will happen if we apply force at this point? the crate will rotate وكأنه بده يقلب. okay. إذا حطينا هون ممانعة على الإدج على الطرف وجينا دفينا from this side وكأنه بده يقلب بتصير rotation بطل translation بتصير rotation example. بس إذا كانت الممانعة somewhere between, so if this is the center line, إذا كانت ال friction okay أنا سميتها الممانعة بهذا المكان okay بالتالي نقدر نقول إنه هذا الجسم بيصير عليه translation. okay so إذا كانت الممانعة exactly at the edge okay بصير في عندي tipping over وكأنه الصندوق بده يقلب. so لو اجينا حكينا ال friction factor normal force acting exactly on the tip, this is normal force okay بالتالي إذا هذا هو السنترويد normal force بعيد المسافة هتكون كم؟ 0.5. in this case بتصير في عندي إيش؟ rotation problem لأنه حيصير له لصندوق tipping over وكأنه حيلف about which point? About this point. okay but this is not the case here. So we'll assume that the point of resistance or point of friction will happen somewhere here. So if this is the line of the centroid, here is the centroid. Okay. So this normal force, I will assume it far away a distance which is equal to x, unknown. Okay, and as a result, the friction factor or the friction force, sorry, will be also at this point. So this is a friction force. Okay, so this is assumption. So if I assume like this, I'm assuming that this problem is only rectilinear translation. Okay, and this is translation. Okay, and I will use the equation of kinetic, the kinetic equation of motion for translation. Okay, I will assume that the equation valid for the translation based on this assumption. Okay, but at the end I will verify that my solution is correct or not. Okay, so I will do verification. So from beginning, so we start with the drawing free body diagram. Okay, and to continue on this assumption, because he said here rests on a horizontal surface, so I will assume that this crate slide or translate on this horizontal surface. How we make sure that this assumption is correct? By assuming that the normal force acting on this point, which is far away x from the centroid, where x is greater than 0 and less or equal to the 0.5, which is half the distance. So this distance is 0.5. Okay. So if I solve this problem and find out that x less than 0.5, then my assumption translation is correct. If x, so here is the cases. If x less than 0.5, at the end once I verify, then this is translation and the equation I use them are correct. So this is translation problem. And there is no tipping over. If x If I look for the value of x and I found it equal to 0.5, then this is tipping over. Okay, then this is rotation problem. tipping over يعني قاعد يحصل له إيش شقلبة about this edge. Okay, so this is rotation. So I will check. Let us go back to the solving. So here is the point. Okay, so here we assume that this is the centroid and this n far away a distance which is equal to x. Okay, the other distances is given. So this is 0.8 and this one is 0.5. Okay, so we start with assuming the coordinate system, and then we draw the free body diagram and then the kinetic diagram. Now it's time to substitute the translational equation. Okay, so we'll start with the summation of force in the x-axis, which is equal to m ag centroid in the x direction, and this is the positive direction as we mentioned earlier. Then what do we have? Which force acting on a horizontal? So we have this force, the applied force, and we have the friction force. Do we have any other force? No. So the applied force in the positive direction, the friction force in the opposite direction, and this is equal to mass of the grate multiplied by mgx. From definition of friction factor or friction force, sorry, the external force minus where, let me write it here, where friction force equal to the kinetic friction coefficient multiplied by normal force, and this is equal kinetic coefficient or friction coefficient given in the statement of the question, which is 0.2 multiplied by normal force. Then if I go back to this equation, I can write the external force minus 0.2 multiplied by normal force, and this is equal to the mass of the crate is 50 multiplied by this is unknown. Okay, so instead of writing the external force unknown, I can write it 600, which is given again. So I can name this equation as equation 1. This equation has two unknowns. Let us see another equation. So summation of force in y direction, and here is the positive direction for this assumption. This is equal to mass multiplied by ag in the y direction. But the crate translates horizontally. Do we have acceleration in the y-axis? Let's go back to the kinetic diagram. In the kinetic diagram, we have only mg or acceleration in the x direction only. So here, simply, we can write this is equal to 0. Its value is 0. The crate will translate only. Okay? It will not fly. Okay? فقط بيمشي horizontally. Okay. So the question here, how many forces we have in the y direction? We have the normal force in positive direction, positive y direction, and we have minus weight in the negative direction, which is equal to 0, and from here normal force equal weight, and this is equal to mass multiplied by gravity acceleration. Okay, and this is equal to 50 multiplied by 9.81. Do not use 10 meter per second square, always use 9.81. So avoid approximation. So 50 multiplied by 9.81 gives us 490.5 Newton. Okay, so this is the normal force. Now if I go back to equation 1, so let me name this equation as 2. So substitute equation 2 in 1. Then what do we have? We have 600 minus 0.2 multiplied by 490.5, and this is equal to, let me go back and check, 500 or 50 multiplied by AGX. 50 multiplied by AG, acceleration of the centroid in the x direction. And from the previous equation, we can say that AGX equal to 600 minus 9.8.1 divided by 50, and this is equal almost 10 meter per second square. So this is the requirement of this problem. Do we finish? Do you finish? You must answer no. Why? Because we need to verify. We need to verify that x greater than 0 and less or equal 0.5. Okay? Or do you know what? Remove this one. We need to verify that x between 0 and 0.5. Why this assumption is important? To prove that we have translational problem. Okay? Now, in order to verify, we end up with one equation, which is the summation of moment about which point? About the, you can take it around any point, so I'll take it around G. And once the assumption is translation, so the summation about centroid equal to 0. So which force do moment about G? Let me go back to the slide and let me erase everything here. So we have force here. Here is the centroid. Of course, we can find out the forces from the free body diagram. So I will draw it again in here. Make it easier on me. Okay, and we assume that we have, this is normal force, which is far away vertical distance equal to x. Okay, and we have friction opposing the direction of motion, which is friction factor, friction force, sorry, and we have weight passing through the centroid. So now the question is, which force does moment about G? So this external force, if I draw its action line, so it is far away, a distance which is equal to how much this distance. So if it is here 0.5, because this is square crate, this is 0.5, then 0.8 minus 0.5 equal to 0.3. Okay, so it is far away, distance 0.3. So this force does moment about G. How about weight? Weight does not do anything because it passes through point G. Now how about normal force? Yes, we have perpendicular distance x. Okay, and here is line of action. How about friction force? Again, friction force far away distance, which is 0.5. Okay. Now remember that the assumption that we start with, that the counterclockwise is positive. Okay, so let us see. So if you use your right hand, this force will do, imagine that here is the force, okay, and you put your right hand, then you will find that this force, let me change the color for you. So you'll find that this force will act a moment clockwise, so its sign is negative. How about friction force? Friction force, if I drag it up to here, you will find that if this is the point of rotation, you will find that again this force, if you use your right hand, this force will do clockwise, which is negative. How about normal force? Let me drag it up to here. You will find that this normal force will rotate counterclockwise. So using right hand, okay, right hand. Okay, so this is negative, the friction force negative, and the normal force positive. So let me go back to the solving board. So summation of moment about G equal to 0. We have negative force coming from the external force, and it is far away distance 0.3 multiplied by 600, okay, minus friction force, which is equal to 0.2, the friction coefficient, multiplied by normal, which is 490.5. This is the friction force, which is equal to mq kinetic coefficient friction multiplied by normal. And this force multiplied by distance, which is 0.5, plus normal force multiplied by x, multiplied by normal force, and normal force we found it previously, which was 490.5, equal to 0. Now the only unknown is x. So if I put x in one side and everything else in the other side, so x equal to 180 positive plus 49.05 divided by 490.5, and this is equal 0.467 meter. And now we can say that our assumption that the crate will translate is correct. Why? Because x, which is equal to 0.46, greater than 0 and less than 0.5. Then our assumption is correct. Which assumption? That the crate is translate. So this is the first problem. Okay. Now let's see another problem. So here is the answer, which is 10 meter second square. Okay, let's see another problem. Here is the second problem. Here we have a hand cart. This is hand cart. Okay, has a mass. So this is mass of the hand cart. Okay, and center of mass at G. So we defined this question defined the mass center for us. Determine the normal reactions at each of the two wheels at A and B. So here we have a reaction force NA, and here we have another reaction force NB. Okay, so this is NA. Okay, and there we have. If a force, this is a force, equal to 50 Newton is applied to the handle at this point, so you can tell easily. Of course, we'll assume this is positive x, positive y, and here is the rotation, the positive direction of rotation. So we can tell that this force will have one component in x direction, and we have another component in negative y direction. So in the negative y direction, this is equal b. This is the theta sine theta, or sine 60. And the other b cosine theta. Okay? Okay. Neglect the mass of the wheels. Okay, so we have only mass of the crate, which is downward. Okay, let us go to the solving board and starting with drawing the free body diagram. So here is the free body diagram. We have a crate. Here is the handle. So this crate has centroid, and on the centroid we have the weight, and we have on wheel A and B. Let me erase this one. Okay, so this is free body diagram, and here we have normal force A, and here we have normal force B. Okay, and here we have external load, external force, and this external force has two components, one on the x direction and the other on the y direction. So this is Vx, and we have here Vy. So the question asks us to find normal force at V and normal force at A. Now the other diagram is for the kinetic diagram. This is the kinetic diagram. So you can tell easily that this crate will accelerate on the negative x-axis. So this is m ag on the x direction. Do you have any other kinetic? Do you have rotation? Nothing. Okay, just translation of the centroid. Okay, the centroid will not do any rotation. So now we can start with the equation of motion. So we'll start with the first one as usual. Positive x direction, summation of force in x direction equal to m AG X direction. Okay, how many force we have? Let me go back. So we have this force, X direction. Do we have any other force? He said neglect the mass of the wheel, so we'll neglect also the friction with the ground. Okay, so there is no friction. Okay, no friction. So we have only B in X direction. So Bx, or instead I can write B external load, okay, multiplied by cosine theta, which is 60. And this is equal mass of the hand cart, which is 200, multiplied by AG X direction. So this equation has only one unknown, because B is given, which is 50. So let me erase it and write 50. And it acts in the negative direction. Sorry, I forgot that. Okay. And by the way, the acceleration itself is, so let me emphasize this point. So this acceleration directed to the negative x direction, and as well as the acceleration. The acceleration acts on to the negative direction, as you can see from this drawing. Okay, and also this one. So this acceleration in towards the negative x direction. So from here we can calculate the acceleration. So acceleration of the centroid toward the x-axis equal to 0.125 meter per second squared. Okay. Now let's continue. Let's move now to the second equation, which is summation of force in y direction equal to, what do you think? Equal to m a, sorry, this is a g in y direction, and this quantity equal to 0, because the handcart translates in x-axis. It will not fly. If you put for this term value, then you assume that this cart is flying or traveling in an inclined surface. Okay. So what do we have? If you refer to the free body diagram, you will find that we have N normal reaction on A on the positive direction, plus N B again in positive direction, minus weight of the cart, minus B in y direction, okay, which is equal to B sine theta, and this is equal to 0. Now NA and NB unknown, so NA plus NB unknown, but we have the weight since we have the mass of the craft, and it's equal to 200, the mass multiplied by 981, do not approximate to 10, okay, minus the external force given 50 multiplied by sine 60. This is equal to 0. From this equation, NA plus NB equal to, first term equal to 1962 plus 43.3, and the answer is 2005.3. This is NA us and let us name this equation as equation 1. Now the third equation, summation of moment. Now, around whom it's better to take the summation of moment. So if we take it around G, then the only thing that will cancel out is weight. Okay? But if we take it around B, about this point, okay, so we will cancel out this reaction, okay, reaction NB. Why? Because it's passing through this point, okay, and see every distance is given, okay, and something else. So we'll take it about B, okay. I'll write summation of moment about any other except the centroid, and this is equal summation of moment due to kinetic, okay, about B, okay. So as I said earlier, that this side of equation refers to any external force. So which external force does moment about B? Normal reaction at A, the weight, the applied load in Y direction, and the applied force in the X direction. Okay, but this reaction does not do any moment because it's passing through. Okay, this is about the first part. The second part, okay, I said we can take it from the kinetic diagram. Okay, from kinetic diagram. So in the kinetic diagram, we have only M, A, G, X. We don't have anything else. We don't have acceleration in Y. We don't have rotation, which is I multiplied by alpha. We have nothing. Only we have this one. So this one is force, which is far away, a distance, which is equal to 0.2. Okay. So yes, I must take point B at this location. Okay. So here is point B. Okay. Let's go back to the solving board. And before writing the equation, let me draw again the hand card and everything on this hand card. So I will combine the kinetic and the free body diagram together. So you can notice what do we have. So this is point B. Here. And here we have the wheel A. And here somewhere we have point G. Then let me first start with drawing the external force, and I will use the green color. So here is the normal reaction at A, and here we have normal reaction at B, and we have the centroid. We have weight passing through the centroid. We have pressure, or sorry, force at X direction, and we have force at Y direction. Okay. Now this is the free body diagram. The kinetic diagram, I will draw it using this color. So we have m mass multiplied by agx. So this is the force coming from the kinetic. Now regarding the distances, I will use the red color. So between the centroid, once I will take summation of moment about B, I will care, my care is about point B. So this distance is 0.2, and this distance 0.3. Okay. The vertical distance is 0.2. Okay. And this distance point 4. And this distance is 0.5. I need vertical distance between the force and point B. Okay, remember. Now we are ready to apply the equation. So summation of moment about B any other point except the centroid equals summation of moment due to kinetic about B. Now the forces that will act or will do moment about B will start with normal force, and remember that those are the positive directions. So reaction A will do clockwise if you use your right hand rule. Okay, put your hand on the vertical distance 0.2, 0.3, and your fingers curl them with the normal reaction. You will find that the thumb will act inside the screen. Okay, so your hand on 0.2, 0.3, the vertical distance, curl your fingers with the reaction force A, and you will find that the thumb will act or will directed inside the screen. That means this moment is negative or clockwise. Okay, or this is point B, and you will find that this force will do clockwise moment. Okay, so we'll say that minus 0.5, 0.2 plus 0.3, 0.5 multiplied by NA, which is unknown. Okay, then we have weight. Weight will do counterclockwise. Okay, so counterclockwise means we have positive due to weight, which is 0.2 multiplied by the weight, which is 200, multiplied by the gravity acceleration. Okay, now NB will cancel out because it passes through point B. Now we have Vy and we have Vx. Vx, let's start with Vx, but instead of Vx I will write V cosine 60. So it will do counterclockwise. So I will write plus V cosine 60 multiplied by the vertical or perpendicular distance, which is 0.5. Why it is positive? Because this is counterclockwise. Now By, this is the line of action of this force. Okay, so if it's reached up to this point, you will find out that this force will act or will do clockwise, or better to use your right hand rule. So minus b sine 60 multiplied by perpendicular distance between the line of action and point B, and the distance is point 4. So this is the external forces. Now let me move to the other side of this equation, which is the kinetic. Since we have only one kinetic, which is m ag in the x direction multiplied by perpendicular distance, which is 0.2, and this force will do a moment counter clockwise. Okay, counter clockwise, then it is positive. Okay, you can go back here and you will find out that the line of action is here, and this is the perpendicular distance, then this is counter clockwise. Now the only unknown in this equation is n normal reaction at A, because MAGX, this term we found it in the previous part. Okay, so if we rearrange the equation, okay, we'll find that NA equal to 765.15 Newton. And if we substitute in equation 1, we'll find that NB equal to 1239.3 Newton. So let us check with the slides. So in the slide, NA 383 and NB 620. But we find that NA equal to 765 almost, and NB, Newton force, equal to 1239 Newton. So where is the problem? Why it's not the same? If you notice that, use the highlighter. Determine the normal reactions, because we have at A and at B, at each of the two wheels at A, and we have two wheels at B. Okay, each of two wheels at point A and each two wheels at point B. So this value must be divided by 2 in order to account for each wheel, and this one also must be divided by 2. If we do so, we can get the final answer correct. Okay, so this is the correct answer. So in the solving board, we must write divided by 2 divided by 2. Okay, and by this we finished talking about section 17.b. So next lecture we'll move to the new section 17.4. So remember, once we finish section, you must go back to the textbook and solve the solved example and the suggested example. I'm advising you to visit your textbook and solve the solved example. This is one of the most important example. Why? Because take a look, we have two centroid. Centroid for the rider and centroid for the uh, this bicycle, okay, or the motorcycle. Sorry. Okay, so we have two centroid. So it's very important. See here how he divide the weights for the rider and weights for the motorcycle. Okay, and here is the kinetic. See here, this is kinetic for the rider separated from the kinetic for the motorcycle. So I'm advising you to solve the equation, and here is the way that we solved earlier in this slide. Okay, plus the kinetic plus the suggested problem. See you soon.